153 billion miles. That is the nearly incredible distance that Explorer 1 has put between itself and the Sun since its launch in 1977. No other object has ever wandered such a long way into the depths of space. And although the old spacecraft is known to have even passed the limits of our home system, it continues its journey, unwavering. But since even the best success stories in space travel must eventually come to an end, a central question arises: how long can Explorer 1 keep flying before it finally runs out of juice, or we lose contact with it? And then, of course, there is the world-famous 1990 picture that shows our Earth as a minuscule blue speck from a distance of 6 billion kilometers. But what might we discover if we were to turn on Explorer's camera today? From today's perspective, it seems almost absurd, but when Explorer 1 set out into the infinity of space on September 5, 1977, no one thought that this was the beginning of one of the greatest success stories in space travel. No wonder, later, all the initially anticipated life expectancy of the identical Explorer probes was only 5 years. What are now the most distant stations of mankind had, at the time, only been launched to gather new insights into the outer planets of the solar system, which had been little explored up to that point. No problem at all. However, after the probes had inspected Jupiter, Saturn, Uranus, and Neptune, NASA decided to extend their mission and finally send them to the edge of our home world. And that's something we simply need to keep in mind. As offspring of their time, the Explorer probes were just built to the technical standards of the 1970s. That amounts to nothing less than their power capacity being multiple times less than that of a modern cell phone. Furthermore, the transmission data of our current cell phone connections is multiple times higher than that of the two old probes. However, this does not mean that Explorer 1 and 2 are chugging through space like dusty old relics. Quite the opposite. They are racing through space at a speed of around 61,000 kilometers per hour. By comparison, the so-called top speed of a gunshot is only 1,260 kilometers per hour. The fact that such breakneck speeds are also crucial in the vastness of the universe is shown by the following. Although Explorer 1 was already on its way to the outer reaches of the nearby planetary system, after passing Saturn in November 1980, it took until August 2012 before it reached the so-called heliopause. As already mentioned, this is the furthest zone of the heliosphere, and consequently, that drawn-out region in which the solar wind, along with its magnetic fields, is effective. Behind the heliopause lies the mysterious interstellar space, or space far from the stars, in which the solar wind's area of impact closes. It is dormant, and how contact with Explorer 1 is maintained is remarkable. At the time this video was made, Explorer 1's journey had already endured 17,280 days, and as mentioned at the beginning, it has since put a distance of 2,477 billion kilometers, or 16,561 astronomical units, between itself and the Sun. To refresh your memory, the length of an astronomical unit corresponds to the mean distance between the Sun and the Earth, which is about 150 million kilometers. On account of the distance that now lies between us and Explorer 1, we are dealing with multiple times the distance between the Sun and faraway Pluto. But how is this vast distance maintained? Or, to put it another way, how do the scientists manage to keep in touch with Explorer 1 at all? Well, first and foremost, a lot of patience. Because, to put it simply, speaking with the probe is actually a difficult process. A signal sent from Earth takes at least 23 hours to reach Explorer 1. On the other hand, it takes almost another day before the Earth-based researchers receive the probe's response. Well, that is, if they actually get a response at all. Of course, in reality, the communication has repeatedly caused headaches for NASA experts. The last time this happened was in October, when Explorer 1 was supposed to turn on one of its radiators, but instead mistakenly triggered a protective mechanism that deactivated the command radio transmitter. To restore contact, NASA finally had to fall back on the S-band transmitter, which hadn't been used since 1981. But luckily, the engineering team was able to detect the weaker signal from this transmitter and continue communicating with the probe. Nevertheless, it's in the nature of things that you can't simply call Explorer 1 in the mysterious universe of interstellar space with just any old cell phone. Instead, specialists used the Deep Space Network, and thus a global network of radio antennas that had to be continuously expanded for the Explorer mission. In fact, the Explorer program is one of the rare projects that requires the continued operation of the large 70-meter antennas and the related receiving technology. This, in turn, involves significant costs. But the time for savings now seems to be in the distant future, when the 70-meter antennas are no longer needed. They can be decommissioned. And scientists estimate this will be the case by the mid-2030s, due to the constantly increasing distance by the Explorer probes. While Explorer 1 is currently more than 24 billion kilometers from the Sun. Sure, here's the text with proper punctuation. This distance is becoming further by 540 million kilometers or 3.6 cosmic units consistently. However, does the last radio power outage spell almost certain doom for the Explorer's venture into the unexplored world? Well, not by any stretch of the imagination, except if something unanticipated happens. The Explorer tests will still be giving testimony about our presence when the human period is logically long finished. And we don't just mean the actual tests, but also the special stuff they carry. This is called the Explorer Golden Record and consists of information plates with pictures and sound data about Earth and its inhabitants. So, we are dealing with nothing less than a message to extraterrestrials, whose estimated life expectancy is 500 million years. Specialists like Stephen Selling, however, have stressed that it may not be the most intelligent plan to expose our world and positions so unreservedly. After all, we can't predict which alien civilization, potentially threatening, will eventually get hold of this data. Be that as it may, Explorer 1 will likely not get very close to aggressive outsiders for another 300 years or so, when it enters the Oort cloud, proposed in 1950 by Jan Hendrik Oort as the origin of significant stretch comets. It is a spheroidal assortment of cosmic objects situated up to 100,000 cosmic units, or 1.6 light-years, from the Sun. However, since Explorer 1 has not yet covered even a single light day between itself and our mother star, it will take another 30,000 years to cross the Oort cloud completely. An additional 10,000 years later, it will again pass by the star G445 at a distance of 1.6 light-years. Conveniently, the star will literally be moving toward its test visitor, as while GLE 445 is presently still 17 light-years from the Sun, it will then have moved toward it to within 3.45 light-years. And assuming that Alan Cummings has his way, the Explorer journey won't be finished for quite a while yet. The C-Tech researcher, who has been involved in the planning and realization of the Explorer program since 1973, is convinced that the two twin tests might still fly for another billion years. Anyway, putting it gently, it's uncertain whether the veteran tests will still be working perfectly from a technical perspective. NASA is already pursuing a severe power-saving strategy, during which more and more instruments are being turned off in order to conserve the rocket's necessary energy. Consider the possibility that we turned on Explorer's camera today. Consequently, the Explorer tests have given us around 67,000 pictures of our solar system, literally giving us a new perspective on our home world. For example, we now know that Saturn is by no means the only planet in the solar system to have rings. The mission has also added various new moons to our star maps. Although the discovery of Jupiter's moon Io had already been recorded many centuries earlier, Explorer 1's pictures provided an exceptional insight into the scarred surface of this unconventional satellite. But Saturn's moons Mimas, Dione, and Titan, and of course the huge gas planets themselves, were captured in an unparalleled degree of detail at the time. But the last photograph welcoming from Explorer 1, the aforementioned light blue dot, was taken nearly 40 years ago. Taken at the insistence of Carl Sagan, it was later voted one of the best photographs in space science ever. The remarkable image once again shows us how small we are in the vast expanse. At the same time, it also raises a key question: what would we really see if we turned on the Explorer 1 camera today? If the probe, once again, complicated and took a final visual glance at its natural home, would anything be visible? We should not forget one thing. In the light blue, taken from a distance of 6 billion kilometers, our Earth already appears as an imperceptibly small speck, not even 10% of a single pixel in size. Unfortunately, it is quite difficult to reactivate the Voyager camera for a newt's think back. So, devoted test fans must rely on simulations. And although these are not real photographs, the results are still quite impressive. The sun, our strong provider of warmth and life, is little more than a faint, blurred point of light. The planets that circle our host star must be speculated about at best. And while the light blue that still represents the photograph of Earth taken from the greatest distance, the simulation changes our entire infinite neighborhood into a collection of tiny dust grains in a singular motion. However, isn't it interesting that those dust grains also carry our world, our planet, and our hopes and fears? The vastness of the universe is truly hard to grasp, but that is exactly what Explorer 1 would reveal if it were to turn its gaze back to its home planet. And now, we would be happy if you would consider clicking the subscribe button, pressing approval, and subscribing now to never miss another video from us again. We'll see you soon.